Dr. K. Parinivelu, Professor at the Center for Environmental Studies and Director of Center for Climate Change and Disaster Management, Anna University, Chennai. He obtained his PhD degree from Indian Institute of Technology, Madras, Chennai. He worked as project officer for a brief period at IIT Madras and moved on to the Center for Environmental Studies, Anna University in 1992. He was a visiting professor at Chungam National University, South Korea during 2007. He has been teaching courses on environmental chemistry, environmental pollution control, and instrumental methods of analysis since last 27 years. He has guided 75 students for ME and MSc, 4 MPhil, 2 MS, and 15 PhDs. He has published 135 papers in journals and 90 in conference and symposiums. He has received several awards in national and international levels.
So, the previous series of lecture, we discussed about photochemical reactions and what are the products formed, etc. we discussed. There also I touched upon one compound called PAN, peroxyacetyl nitrate. Okay. This comes under a category of air pollutant called smog formation, photochemical smog, one of the very important air pollution episode. So, we will see the chemistry behind what are the effects, all those things we will discuss in this smog series or lecture. What is smog? Smog is a combination of two words, namely smoke and fog. And really two kinds of smog is associated with the air pollution issue. One is called reducing smog, the other one is called oxidizing smog. If you look at the first one, reducing smog, mainly arising out of sulfur dioxide, and it was the issue in the London, UK, especially in the 1950s. Because of the stringent air pollution issue, this has disappeared and it is not an issue problem. Why it happened? If you look at the background of this, Europe especially, cold countries, they used to heat the houses to bear the winter snow and other thing. It will all, they use lot of fuels. In the early 40s and 50s, they used fuel rich in sulfur. Because of the heating, lot of sulfur dioxide was released, that because of the cold condition not dispersed out, everything condensed and they form the smog, which is nothing but smog containing sulfur dioxide, which is highly dangerous. And British government enacted various stringent regulations to eliminate this. Now, this is not a problem at all, because the fuel used for room heating is very low in sulfur. So, this problem is not an issue. The other smog, what is called oxidizing smog or popularly called photochemical smog, this is one of the very important air pollution issue, and especially this problem was started in Los Angeles, USA, and many other cities. Not only this, first time it was observed in there, and many other part of this globe also, like Tokyo, Paris and Mexico and other part of this globe also, they observed this phenomena of photochemical smog. And the common thing with the both oxidizing and reducing smog as eye irritation and lung damage, and they can also severely affect the agricultural effects, that is the food product arising out of this exposed smog materials also is a problem. Okay. So, we will see the details, what is this photochemical smog in details now. The previous lecture itself I mentioned about photochemical process, okay, that is the reaction carried out with the light, and we discussed some of the important chemical reactions arising out of this smog. So, now to photochemical smog to be formed, 4 things are very important. Only all these 4 are available, then only the possibility of smog, photochemical smog formation is possible. What are they? One is warm air, okay, slightly warm air is required. Second requirement is lot of intense sunlight. There plenty of sunlight should be available, that is photochemical process to start, that should favor. The third requirement, lot of hydrocarbons and NOx should be present. That means usually both comes from running of cars, and that is also another requirement. And fourth requirement is there should be the air mass should be stable, not much turbulence should be prevalent. That is, a city is surrounded by mountains is ideal. So, four requirements are warm air, solar light, lot of hydrocarbon and oxygen and nitrogen pollutants should be prevalent, and there should be a stable air mass. What are the hydrocarbon and NOx discharge should remain there. If all these fours are met, then there is a possibility of photochemical smog formation, and the city Los Angeles in USA meet all these requirements. So, first time they reported this smog formation there, and because of this smog is also known as Los Angeles smog or photochemical smog. Now, we will see the chemical reaction involved during the formation of photochemical smog. One of the first requirement is nitric oxide formation should take place. That is, the nitric oxide formed in the engines is relatively non-toxic and not capable of absorbing UV light and does not initiate any photochemical reaction. That is simple reaction, nitrogen reacts with NO, and you can ask nitrogen oxygen present in the atmosphere, that also no, the reaction will not take place, will not proceed very easily. There should be a hot climate, very high temperature is required. That is, then the core engine is the ideal one to generate this NO species, nitric oxide species. So, nitrogen reacts with oxygen in the core engine with a very high temperature prevailing in the engine, running engine, generate this nitric oxide. As I told you, this is a non-toxic chemical and not capable of absorbing UV light also. But what happens is, it is readily oxidized by the air oxygen present in atmosphere. So, the nitric oxide reacts with the molecular oxygen prevalent in the atmosphere, gets converted into nitrogen dioxide. So, this is a culprit reaction for this smog formation. So, the nitrogen dioxide formed is a culprit for the reaction. What happens is, the nitrogen dioxide is formed, it is capable of undergoing photochemical reaction, the troposphere. This reaction already we have seen before during the photochemical reactions, that is nitrogen dioxide by absorbing light undergoes dissociation to NO plus oxygen, and this reaction is prevalent in the daytime. When the moment sunlight appears, this reaction is predominant. Also, in the troposphere, the oxygen atom reacts quickly with molecular oxygen, atomic oxygen, producing ozone is possible. This is also we have seen earlier, and ozone can react with this nitric oxide, producing nitrogen dioxide. So, the O3 ozone molecule reacts with this NO and bring out or convert it into nitrogen dioxide. So, again this nitrogen dioxide, once it formed, again capable of this reaction, it can undergo this reaction again, and in a way it is a cyclic in the atmosphere. Whenever light is there, it goes on happening in this way. So, the above three reaction result in a fast cycle where ozone is produced through reaction A and B. If you go and see, ozone is formed because of this reaction, but it is destroyed through the reaction C. Ozone react with nitric oxide, again this is formed. So, both it is a fast cycling is taking place. As a result, what happens is, the concentration of ozone quickly reaches a steady state concentration during the daytime with no net production of ozone. So, more or less a steady concentration is prevailing there. And now, there are several steps for making the smog photochemical formation, and we will see how this is happening in a sequential way during a day of a particular reaction. Okay. The first step is core generate NO formation thermally at very high temperature. As I told you before, nitrogen reacts with the molecular oxygen, forms this one first step initiation, that is because of the core running. Next is the peroxyl radical, already we discussed, formation is taking place, produced, oxidize the NO emission to NO2 also, which gives the smog formation. Okay. So, the peroxyl radical react with NO, generate hydroxyl radical, I am sorry, here a dot, hydroxyl radical, again NO2, and any alkyl or group, both saturated and unsaturated, this is one of the intermediate product of this hydroxyl radical attack. First one can react with the NO in presence of molecular oxygen to form alkyl oxy radical plus NO2 and hydroperoxyl radical. See, these species are collectively called smog formation, usually yellow color smog formation there. The moment yellow color is present in the atmosphere, some oxides or nitrogen compound is present, that is a clear indication smog thing. So, wherever if you see nitrogen oxide is present, that will give you a color. And one of the popular chemical reaction for nitrogen compound nitrate functional group is a ring formation. The qualitative test to test any nitrate salt is there, brown ring test popularly called, that is because of this nitrate formation. So, nitrogen oxides containing compounds usually give a yellow color, including this smog. So, the third step is the conversion of NO emission from cars to NO2 by the reaction of carbon monoxide and hydrocarbons. Also, carbon monoxide is also one of the product of incomplete combustion, and hydrocarbon that increase the concentration of ozone during the day, and the nitrogen dioxide and hydrocarbon can react with the aldehyde like acetaldehyde, ozone, and that will bring out what is called peroxyacetyl nitrate, PAN, popularly called PAN. This is one of the very important compound of photochemical smog. Photochemical smog is not a single compound, it is a mixture of compounds consisting of all this. One of the very proven compound is peroxyacetyl nitrate. For example, the hydrocarbon released ethane CH3CH3. How this leads to formation of PAN is given here, and you can notice what was the photochemical process, what we discussed, how the saturated hydrocarbon reacts with the hydroxyl radical leads to the PAN is a consequence. There also I told you. So, here the ethane molecule reacts with the hydroxyl radical generated through photochemical process in the atmosphere, generate this ethyl peroxyl radical species. This species can react with the NO with the molecular oxygen presence, leading to the formation of aldehyde, acetaldehyde is a product. This is one of the intermediate product, as I told you before, any photochemical process aldehyde, hydrocarbon to aldehyde, this compound will form. This aldehyde can again react with the hydroxyl radical, generate another radical species. Okay. This radical species further reacts with molecular oxygen present in the atmosphere, forming this peroxyl radical species again, but the excess oxygen can react or combine with the NO2, forming this PAN, peroxyacetyl nitrate is a compound. This is one of the very popular proved compound of photochemical smog, and the structure is shown here. And this compounds, PAN compound, are proved eye irritant. If they are there, if you get exposed to eye, it immediately cause irritation. In addition to this PAN, peroxybenzoyl nitrate is also possible. For example, if benzene aromatic hydrocarbons are present, definitely they are also capable of reacting in a similar way, and they form what is called peroxybenzoyl nitrate, PBN compound. The structure is shown here. This is aromatic, this is aliphatic. So, the PAN compounds, all this are part of this photochemical smog formation. Predominants are these are the compounds. Now, the photochemical smog formation is clearly proved it is happening only because of the sunlight, and that is why it is all listed as one of the very important requirement. If only night is there, no sunlight is available, this is not possible. The formation of PAN is not possible. How this is proved as clearly displayed in this graphical representation. What is done is the x axis time of the day from midnight to next day midnight, they have monitored the different concentration of pollutant responsible for this formation of this PAN. Okay. Pollutant level, they have monitored NO, NO2, hydrocarbon, aldehyde and oxidant. So, all these parameters are monitored in a particular location where photochemical smog formation is happening, they have monitored it. Okay. So, midnight to 24 hours monitoring is there. So, midnight it is all low. At 4 p.m. I am sorry 4 a.m. early morning, people will start moving to office, workplace they will go. Okay. And they used to drive the car. Ultimately what happens is, if the cars are running, more amount of NO and hydrocarbons will be released. That is why the concentration goes on increasing, NO concentration is increasing and hydrocarbon concentration is also increasing. This is because of vehicle movement. The car engines, they liberate NO and hydrocarbon, unburned hydrocarbon also. Okay. After 8 o'clock, that is sun sets in, sunlight comes, you can see more formation of NO, aldehyde and oxidant is taking place. This is because of whatever the hydrocarbon emitted undergoes photochemical reaction, and this is also all this nitrogen species also react with this, and initially aldehyde formed and also oxidant. The oxidant formation is also happening, that is PAN compounds all happening. This is all prevalent in the noon time, maximum concentration you can see there after the sunlight appears. This is high, the oxidant concentration is very high, similarly aldehyde concentration is also very high at the noon time because of the sunlight, and again evening you can see there started decreasing because there is no sunlight after the sun sets in, the oxidant concentration, aldehyde concentration drops. Okay. Because no light available, the photochemical reactions are stopped, ultimately the oxidant and aldehyde concentration comes to a halt, and at midnight almost steady, lower concentration. What was started the next day midnight, if you observe it, it comes to a halt. So, this clearly the concentration monitoring of these pollutants clearly indicates the PAN or photochemical smog formation is induced by sunlight coupled with pollutants like NO and hydrocarbons. This is essential species for this photochemical reaction to take place. Now, the smog is formed. What are the effects of this photochemical smog? Okay. And they harm the normal living of people, and this smog, some of the main issues or worry are, it affects human health. As I told you before, it is a eye irritant, and it affects the human comfort, the smog formation. Apart from that, it damage to material, causes material damage, and affects on the atmosphere also. Visibility, everything is affected, and not only this, and affects the plant materials things, acts as a toxic to plant material, because most of the smog is oxidizing in nature that destroy the plants and other food products arising out of the plant material. So, in this way the smog is a harmful one in nature. So, it has to be controlled seriously, otherwise we will see some of the what are the human health in little elaboration we will see. The exact degree to which exposure to smog affects human health is not clearly established, although substantial adverse effects are suspected. Okay. Mainly the photochemical smog are pungent smelling. There is a smog produced indicate ozone may be present. Okay. The oxidizing smog, ozone may be present through the photochemical reaction is possible. and ozone at 0.15 ppm causes coughing, wheezing, bronchial constriction and irritation to the respiratory mucous system in a healthy individual. Okay. Normal persons, if they are exposed to 0.15 ppm of this ozone or photochemical smog material, they cause human respiratory and other issues. In addition to ozone, the other components present in the smog like peroxyacetylenitrate PAN and aldehydes found in smog are eye irritants. So, it causes eye irritation, visibility is affected and also breathing issues is a problem with this photochemical smog and ozone compound. More importantly, they affects materials adversely. One of the main thing is rubber material. Okay. This rubber material, when they are exposed to this photochemical smog, material damage is happening. Okay. Why this is happening? Because mainly the rubber material, as shown in this diagram, contains double bond. Okay. This double bond is a very special liking for ozone and form ozonoid chemical initially to start as intermediate. This is a very highly unstable and undergoes degradation, forming aldehyde acids and variety of compounds. Okay. So, that it starts with cracking of rubber. Okay. The moment natural rubber material is there or ozone, if they are exposed, it causes material damage by oxidation reaction, breaking the double bond. In a cessation type, cessation of the double bond is taking place, leading to the deterioration of the polymers through breaking, leading to the formation of various intermediate compounds. Okay. So, this is one of the very critical issue, material damage by this oxidizing smog. And plant materials is also affected, as I told you before, especially young leaves are affected by this oxidizing smog and leading to bronzing and glazing of the surface of the leaves. That is a first initial thing because of the toxicity to the smog material. And exposure for several hours to an atmosphere containing PAN at a concentration of 0.02 to 0.05 ppm will damage the vegetation itself. That is, the sulfhydryl group will damage the material, that is vegetation, because of the protein mostly contains sulfhydryl group of this living organism, and that is attacked by PAN. This peroxyacetylnitrate attacks this, causes oxidation of this compound, and because of the PAN, and also PAN contain acetyl group, it acts as an acetylating agent. So, two ways, that is one way through oxidizing agent damage this protein molecule, the other one through acetylating reaction also it causes a damage to the vegetable material. And because of this, ultimately what happens is the product obtained out of this plant materials not only leaves, the products also inferior quality, the food grains gets out of this material is also, and brief exposure to approximately 0.06 ppm ozone may also temporarily cut photosynthesis in plant materials and affecting the normal photosynthesis process. So, these are the some of the damages caused to the plant materials by this photochemical smog. So, obviously it has to be controlled. So, what are the steps needed to control this? To control this, we have to analyze how it is originated. Okay. So, what are the reasons for this formation of smoke and this one? So, as I told you before, the car is the main culprit. The car emits NO and hydrocarbon. These emission has to be controlled. If we control this emission, definitely the photochemical smog can be controlled, because these are the two precursors material comes from the running of the car, that is hydrocarbon emission due to the unburned hydrocarbon, and the engine by reacting with the nitrogen and oxygen, as I told you before, generate NO. So, these are the two material that should be cut and should not be allowed into the atmosphere. So, this is done, definitely we have avoided the issue. Automobile industry did considerable research on this aspects, and they have come out with a solution. Almost this problem is now eliminated throughout the globe, the smog formation. Okay. Earlier engines emitted about 9 gram of hydrocarbon per mile car. Now, lot of improvement in the engines modification, everything is done. Now, the current rate, it is very low, about 0.4 gram per mile is the current emission of hydrocarbon. So, considerable reduction of hydrocarbon is taken place due to the engine modification. So, this is first step in controlling the photochemical smog formation. And another one is catalytic converter, and this catalytic converter function in two ways. That is why it is called a two-way catalytic converter. The first stage in this catalytic converter uses ruthenium catalyst compound. What it does is it reacts with this NO and converts this NO into nitrogen molecule. Okay. So, this is not a pollutant. Only if NO is present, that will react and forms NO to all this photochemical smog. The moment NO by reaction with the ruthenium is reduced to nitrogen, nitrogen is an inert molecule. It is already present 78% in the atmosphere. So, it is not capable of reacting with or undergoing photochemical reactions, no issue at all. So, this is a first success in this. And the second stage in this one is platinum or palladium catalyst. What it does is it oxidizes the hydrocarbon, completely converting into carbon dioxide. So, no hydrocarbon molecule. So, no chance of hydrocarbon reacting with the hydroxyl radical, and ultimately the PAN formation or photochemical smog formation is avoided. So, this catalytic converter works efficiently or control the photochemical smog in two ways. One is first converting this NO to nitrogen, harmless nitrogen, and second one, any hydrocarbon is there, that is oxidized completely to carbon dioxide, no chance of hydrocarbon. So, that way this photochemical smog formation is controlled through this catalytic converter reaction. So, by this very clear, if automobile industry now also they have come up with a lot of modification, even from 4 to 6 have come, that also further reduces all this emission things, ultimately make this problem is eliminated. So, in this series of lecture, we discussed about photochemical process taking place in the atmosphere, how hydrocarbons emitted, that is both volatile organic hydrocarbons are consisting of saturated and unsaturated hydrocarbon emitted in the atmosphere, how they react with the hydroxyl radical, forming variety of aldehyde, acid and carbon dioxide, that mainly we discussed. And in connected with that, one of the very important air pollution episode, namely the oxidizing smog or photochemical smog or Los Angeles smog, also we have discussed the chemistry behind this formation of PAN, peroxyacetyl nitrate. We discussed the chemistry behind it and how this photochemical smog affects the human health, material damage as well as plant materials, everything we discussed elaborately, and ultimately how to control this problem. That is what very important, how we can eliminate. So, the precursor material responsible for this photochemical smog, namely oxides of nitrogen NO and hydrocarbon, that is completely prevented from car engines. So, even natural condition prevailing, if there is no precursor material, ultimately they will not lead to the formation of this photochemical smog formation. So, by proper air pollution control, stringent air pollution control measure, we can avoid this phenomena of photochemical smog which is leading to loss, lot of loss, health as well as material loss. So that completes the end of this session. Thank you.